quartile deviation. Quartile deviation. Now, what is the quartile deviation? That is also connected with the term quartile. In the case of median, we have already found the decile, quartile, like that. That is also has another name. That is another name is the semi-interquartile range. That means that is also a type of range. That is practically is a measure of spread. Why spread? Because range is also a spread from 10 to 40, from lowest value to highest value, is a measure of spread based on differences between the, in that case, quartiles, as these differences are expected to increase or sometimes decrease with the increase, or when that is decreasing, that is decrease in variability of the data. Okay, and the formula, or that is the definition of QD, that is in small, called as quartile deviation or QD. That is the arithmetic mean AM of Q3 minus Q2 and Q2 minus Q1. That means you can say the Q3 minus Q2 plus Q2 minus Q1 divided by 2. Now you can subtract the Q2. We are writing like that: Q3 minus Q2 plus Q2 minus Q1 by 2. Each and every Q is practically our quartile. So that one is becoming like Q3 minus Q1 divided by 2. And that is our the quartile deviation. Let's check what the quartile deviation gives us with some example. Suppose the question has been given like that. Before already we have done some example on quartile. So here another one, and we are finding the quartile deviation also. Find lower and upper quartiles. That means Q3 and Q1 for the following data on the number of hours spent in watching television last week for 10 students. Suppose 18, 7, 15, 27, 22, 20, 24, 27, 30, 12. Now, for quartile deviation or to find out the quartile, we have to rearrange the data at first. Suppose we are arranging the data in ascending order. So the order should be 7, then 12, then 15, then 18, then 20, 22, 24, 27, another 27, then 30. So how many n's are there? How many items? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10 here. For quartile, for median, we have to find out the n plus 1 by 2 for quartile. So for quartile, n plus 1 divided by 4. That means 11 by 4 is equal to 2 plus 0.75. Okay, that means, and that is for the quartile 1. And for quartile 3, that should be 3 into n plus 1 divided by 4, the third one, that is 33 by 4, or that one is the 8 plus 0.25. That is for quartile 3. So we can find out the quartile 1 at first. Quartile 1 is equal to, that means the second value. The second value, that one is the 12. The second value, then the 0.75. So the second value plus 0.75. That means the third value minus the second value. Okay. So here that one is becoming 12. That is our second value. Then plus 0.75 into third value is 15. Second value is 12. So 15 minus 12, the result is 14.25. So once again, if you want to find out the quartile, that is for ungrouped data, the second value is here as 11 by 4, 2 plus 0.75, then second value plus that one. Then what is the third value? That means the quartile 3. Now look at the quartile 3, that is 8 plus 0.75. So that is 8th value plus 0.25 into the next value, 9th value minus 8th value. So let's check what is the 8th value and 9th value. So 10, 9, 8. So that is our 8th value and that is our 9th value. So the result is here, that is 27 plus 0.25 into 27 minus 27, or that is 27. Now, if we want to find out the quartile deviation. So quartile deviation means, look at the formula. Quartile 3 minus quartile 1 divided by 2. So if we want to find out the quartile deviation, that is Q3 minus Q1 divided by 2, or 27 minus 14.25 divided by 2, or that is 12.75 by 2, or 6.375. That is our quartile deviation. So when we have to find out the quartile deviation, at first find out the quartile 3 then quartile 1, then add, and after that, sorry, and add, after that number subtract and then divide it by 2. That means quartile 3 minus quartile 1 by 2. So from the measure of uh, variability or dispersion, the first one was the range, the second one was the quartile deviation. Now for the quartile deviation, we have to find out the quartile 3 and quartile 1. It may be from the ungrouped data or from the group data. Already the previous problems, whatever you have solved, that one was based on the group data. That means the classes has been given. We have found. Now that one is for the ungrouped data. How we can find out the quartile, and then how we can find out the quartile deviation. It is easy than the group data. Okay. Now some merits and demerits of the quartile deviation. So merits of quartile deviation. First of all, quartile deviation is easy to calculate. The second one, this is not affected by the presence of extremely large or extremely small item or data or values. Number 3, now that means the outlier. Then this measure is suitable for distributions with open end class. Now that is important. What is the meaning of open end class? Already, suppose some classes has been given. I am writing here 100 to 200, 0 to 100, 200 to 300, 300 to 400, 400 to 500. That is the type of class. Now from here we can also find out the range, because that is our lowest class, that is our highest class. So which one is the higher value? That is the 500. Which one is the lower value? That is 0. So we can find out the range, that is 500 to 0. We can also find out the quartile deviation from here, from these classes. Now another one class suppose has been given. That means below 100. That means the lower class has open end. So below 100 it may be anything. Then from 100 to 200, 200 to 300, 300 to 400. Upper 400. That means greater than 400. So that is another open class. Now in that case, when below 0 is given, we cannot find out the range because there is no lower value. Same as the highest class, we have no upper value. So range is not possible, but quartile deviation is possible here. So for the quartile deviation, open end class is not important. So we can find out the quartile deviation for open class also. Now some demerits of the quartile deviation. Number one, quartile deviation does not consider all observations, in the data set. So there is a limitation. Number two, this is highly affected by the sampling fluctuations. What is the meaning of sampling fluctuations? Like we have some data, 1, 2, 3, 10, 29, 5, 7, 9, 39, 75, 4, like. So some data are fluctuating. Suppose if we have some ranges, that is for ungrouped data. Now, when we are thinking about some classes 0 to 100, 100 to 200, 200 to 300, 300 to 400, 400 to 500. Suppose the frequencies are given 5, 7, 79, 4, 3. Now, look, there is a fluctuation from 7 to 79, a big fluctuation, another one fluctuation. So when we are finding the quartile deviation or simply the quartile, that means quartile 1, quartile 3. So in that case, the quartile 1 will be affected, quartile 3 would be affected. So when that type of quartile is affected, calculation of what the values of quartile is affected, simply the quartile deviation would affected also. So that is why the quartile deviation highly affected by the sampling fluctuations. And another one, there is little scope. There is little scope for the further algebraic treatment. What is the meaning of that? Now, suppose we have another data 0 to 100, 100 to 200, 200 to 300, 300 to 400, 400 to 500. And the frequencies are given, not big fluctuations. Suppose 5, 4, 9, 7, 5. So we have founded the quartile 1, we have founded the quartile 3, so we have founded the quartile deviation. All are okay. Now after the calculation, it has been found that 200 to 300, actually the data, the frequency is not 9. Suppose that is 8. So we have to check it once again. That means we cannot simply do any calculation to correct the quartile deviation. That means once again, for that particular frequency changing, we have to calculate the quartile 1 once again. We have to calculate the quartile 3 once again. Then we have to calculate the quartile deviation once again. So that means little scope. We have to start from the scratch. That means from the start for the further algebraic treatment. That is not possible. From some position we are changing it and we are recalculating to correct it. No, we have to start from scratch. So that is a big problem when we have a big data. So Those are the merits and demerits of the quartile deviation. Another one thing for the quartile deviation, that is quartiles from quartile deviation for a symmetric distribution. Now, what is that symmetric distribution? Because of the fact that Q1 and Q3, quartile 1 and quartile 3, are equidistantly placed from the median is a symmetric distribution. The quartiles can be obtained from the following relation. That is, quartile 1 is equal to median minus quartile deviation, and quartile 3 is the median plus quartile deviation. Let's check why. Already we had that type of data. Suppose that one is the starting position, that one is the end position. So where the median lie in between. So that is our median. Because median divided into 1, 2, two equal intervals. Then what is quartile 1, quartile 2? That is the quartile 1, that is the quartile 3. Already we know that. Because quartile divides the total interval into 4 equal parts. So that one is our quartile 2. So when we have the quartile deviation, that means that one is the quartile deviation. Median is already, we know, that means quartile 2. That one is the quartile 2, that one is the median. So we have to find out the quartile 1 because that one is the quartile deviation. So Q1, as usual, that is quartile 2 minus quartile 1, quartile 3 is equal to quartile 2 plus quartile deviation. So simply quartile 2 means median minus quartile deviation, and that one simply median plus quartile deviation. So from that position also, we can find out if we have the quartile deviation and also we have the median. We can find out the quartile 1 and quartile 3. Finally, these relations, that means these two relations, these relations hold good even if the distribution is moderately skewed. Now, skewed means already we had some type of data, that is skewed to the left, that is skewed to the right. What is the symmetric distribution? that is the bell shape, that is the symmetric distribution, that is skewed to left, that is skewed to right, that is the bell distribution, or that is also called mainly the symmetric distribution, that is the bell shape. So that is the quartile deviation. First one is the range, second one is the quartile deviation.